Okay, this lesson is going to be on finding the greatest common factor when you're looking at a polynomial. So here's some examples, and you'll have a worksheet to go on with this as well. So we just look at each one and say, what is the biggest number and what is the most amount of letters that I can take out? So we're going to look at number one here first. So the biggest number that I can factor out of these, or what is the biggest number that you can divide out of both of these, is going to be 2. Okay, so I'm going to write that up front. And then the most number of letters or variables that I can take out is always going to be your smallest one. So I have x to the second here, and I have x to the first here. So my smaller one is just to the first power, because we can't take away 2 from 1, but we can take away 1 from 2. So then you're going to divide each piece by this, 2x and 2x. Okay, and what's left over goes into parentheses. So we factored out a 2, and we factor out an x. 8 divided by 2 is 4. We had 2 x's, we took away 1, so we're left with 1. 10 divided by 2 is 5. We had an x, we took it away, so we have none left. And that's your final answer. Okay, let's move on to the next one. So I need to figure out the biggest number and the most amount of letters that can come out of this one. So the biggest number I could take out would probably be a 4. And for letters, there's a y here, but there isn't any y's here, so I can't take out any letters, so it's just going to be 4. So we're going to divide each piece by 4. 12 divided by 4 is 3, and bring down that y since I didn't divide it out. Minus 16 divided by 4. Negative 16 divided by 4 is negative 4. And there's my answer. Okay, now we're going to move on to the next one. The biggest number that I could take out of both of these, I believe, is 15, because 15 goes into 45, so I'm going to go with 15. And I have 5 D's here and 3 D's here. So I can only take away the smaller one, so I'm going to take away 3 D's. So I'm going to divide each piece by 15. I didn't leave a lot of room there. D3. 15 D3. Okay, negative 15 divided by 15 is going to be negative 1. I had 5 D's, I took away 3, so I'm going to have 2. Sorry for my sloppy handwriting. 45 divided by 15 would be 3. I had 3 D's, I took away 3, so I have none left. Okay, so we're going to keep moving on here. Same process over and over again. So look at this one. And the questions on the EOI will be like, what is the greatest common factor? And a lot of times they'll just be asking for this piece right here. Like, what is the greatest common factor? What's the biggest thing you can take out is what they're asking. And they'll give you something that looks like this and say, what's the greatest common factor? For this one, we can take a 6 out of each piece. Okay, we have 2 ends here, 1 in here, but none here, so then we can't take out any ends. So we're just going to divide each piece by 6. And that leaves me with n squared. Negative 30 divided by 6, negative 5. Bring down that n. And then 42 divided by 6 is 7. Okay. So it just keeps working like that. Let's do another example. Okay, with number 7 here, I have negative 7, negative 10, and 17. Well, 7 and 17 are prime. There's nothing I can divide out of either of them than 1. So I can't divide anything out number-wise. Now looking at my m's, I have 2 m's here, 1 m here, and none here. There's nothing I can divide out. So on one like this, we're just going to call it prime. The whole thing is prime. There's nothing we can factor out. And then just move on. Okay. This one, want to figure out what's the biggest number and what is the biggest letter that we can take out. Now, 18 and negative 50. I'm trying to think. The only thing I can come up with is 2. So we're going to try 2. Now, if you factor something out and then you look at what's left over and, oh my goodness, I could have factored something else out, then just erase it and start over and come up with a bigger number that you could factor out. But I think 2 is it for that one. And then we have 2 x's here and 2 y's here. So we don't have anything in common in these two terms. There's nothing that we can factor out as far as letters. So just 2. Just divide each piece by 2. 18 divided by 2 is 9. And then x squared, just bring that down. Negative 50 divided by 2 is negative 25. And then just bring down that y squared. And that's it. Okay. Moving on. Sometimes they'll give you mixed ones like this. And that's pretty common on the EOI of having 2 different kind of letters. And so we'll look at some of those. So just like the other ones, we want to figure out what's the biggest number that we can take out. A lot of times it's just this first number like it was up above where it was 15. So I'm going to see, off the top of my head, I'm not sure if 108 is divisible by 36, but I'm going to try it. Yes, it is. It goes in there 3 times. So that's going to be the biggest number we can take out is 36. Okay, so I've got my number. Now I'm going to look at my letters. I have 1 R here and 2 R's here. Remember, I can only take out the smallest one. So I'm just going to take out 1 R. Here I have 2 S's and 3 S's. Once again, can only take out the smallest, so I'm going to take out 2. Okay, then everything left goes in the parentheses, so I'm going to divide each piece by 36 RS squared. 36 RS squared. Okay, 36 divided by 36 is just 1. You can write it or, be invisible. That's fine. We had 1 R, we took away 1, so there's nothing left. We had 2 S's, we took away 2, so there's none left. So I guess, yes, we'd have to leave a 1 there because that whole thing just canceled out. Okay, so negative 108 divided by 36 is negative 3. I had 2 S's, I took away 1, so I have 1 left. I had 3 S's, I took away 2, and so I have 1 left. And so that would be your final answer. Okay, one more example, and hopefully you'll be set, but if you need additional help, of course, please let me know. So here, we're going to look at our numbers. We have a 2, a negative 3, and a 4. There is nothing that they have in common but 1. So we're not going to have to factor anything out there. So let's look at our letters. I have 5 C's here, 4 C's here, and 3 C's here. I can only take out the smallest amount, so I'm going to take out 3 C's. Okay, I have 4 D's, no D's, and no D's. So it looks like all I'm factoring out of this one is C cubed. Okay. So I'm going to divide each piece by C cubed. Remember why I say divide, you had done this in Plato. When we divide exponents, we subtract them. So 2 divided by 1, we'll just have 2. We had 5 C's, we took away 3, so we have 2 left. Okay, we didn't do anything with the D's, so that stays the same. Okay, negative 3 divided by 1 is negative 3. We had 4 C's, we took away 3, so we have 1 left. Okay, 4 divided by 1 is 4. I had 3 C's, I took away 3 C's, that should be 3. So I have none left, so I'm just left with 4. And that would be your final answer. So that is how you do greatest common factors when you're dealing with polynomials. Like I said, on the EOI, they'll most likely ask you, like, give you a polynomial like this and say, what's the greatest common factor? And they'll have you usually pick out this front number, or they may show you 4 options that are factored and you have to pick which one out is correct. One thing to check your answers, you can always distribute and go back in and see, if you did it correctly. 2x times 4x 2 times 4 is 8. In x times an x, we add our exponents, so 1 and 1, so I have x squared. 2 times 5 is 10. X times nothing here, give me an x. Does that match this one? Yes, so I did it correctly. Okay, we'll do one more like that just to make sure you understand how we can go back in. Let's do this one. 2 times 9, that gives me 18x squared. 2 times negative 25 gives me negative 50y squared. Does that look like this one? Yes, it does. So I did it correctly. And that's how you do it. So let me know if you have questions. Hopefully that was helpful.